Hi, my name is Dennis Brandl. I'm here to talk about the OPC UA ISA 95 Part 4 Job Control Companion Specification and how you can use it to control jobs on production lines, assembly lines, and other type of manufacturing lines. I've been heavily involved in the development of OPC UA companion specifications as well as other ISA, IEC, and ISO international standards. So I hope you find this informative and I hope you find it interesting as we talk about how we can control jobs on equipment using OPC UA. Thank you. First, a little bit of history. The OPC UA Job Control Specification 10031-4 was first released in June 2021. It was developed by a group called OPEN-SCS, the Serial Communication Standard Working Group. This is a standard that is looking at serialization of products primarily in the life science industry, but also in multiple other industries. This was really defined to control assembly equipment, labeling equipment, which you need for serialization labels, packaging equipment, entire assembly jobs, and these sort of things. And it supported the concept of queuing jobs and equipments and lines. After it came out in 2021, the group from VDMA started looking at it and looking at trying to do job control as well. And working with them, we decided that the best way to do this was really to extend the current specification that we had, the version 1, to a version 2 to include some additional machinery and equipment types, to use a state model to monitor and control the jobs, and localized text to basically make it much more robust and much more easier to use and much more general in purpose. But first, just a little bit about OPEN-SCS, the Serial Communication Standard. The goal here was to look at packaging serialization solutions. And because these have to integrate across multiple operations and business process boundaries. So, for example, you have a line serialization controller, which is printing labels and checking the labels and rejecting labels that were badly printed or rejecting products that the labels weren't correctly attached. They had to talk to site serialization manager systems that were managing the exact serial numbers that were out there, as well as enterprise serialization managers, and then finally government and supply chain. Now, if you can imagine, the serial numbers are things that represent something that is sellable. It's a sellable product, and you can use the serial numbers to identify it all the way out to the final customer. This is being required in many cases, particularly in life science, because there's many counterfeit drugs out there, the substandard and falsified drugs that exist out there. So you need to manage these things, and this is where governments and supply chains get involved in the whole situation. Now, we started looking at this, and we developed a set of standards that dealt with the serialization project. And the big thing here was to look at it. How big a problem is this? And again, this is just a little background for you to show you why we were working on this. 10.5% of failure rates in low and middle income countries, $30 billion spent on $30.5 billion spent on substandard or falsified drugs and medicines. Yes, antibiotics were not working, anti-malarial drugs, etc. These are just a couple of the problems that showed up, and we addressed these problems. So the working group developed standards for exchanging serial numbers, but then we also had another requirement coming in. We actually had to control these packaging and printing jobs. So you can think about, again, very similar. These are packaging issues associated with taking a drug, putting it into a carton, putting those cartons into a case, putting the case into a pallet, and every one of those things had to be labeled with specific serial numbers. So what we had to do in the OPEN-SCS, we had the requirement to control the packaging jobs that were on the assembly lines. So we decided to look at the ISA 95 Part 4 job order model that's out there. This has been fairly well developed and fairly well accepted. There's multiple different implementations of this at different levels of the system. But what we're talking about here is something that goes potentially all the way down to a labeling machine or a palletizing machine, because those machines have the printers on them, they have the scanners on them, they have all the controls, the PLCs, and the other things that are down there in a manufacturing line. And we said, okay, each of those things, either the manufacturing line or the big part of that line, is defining some job. And that's the 95 definition. A job order is something that describes a request to produce a job, or could be packaging a material. So we were many times talking about packaging orders. The job order can contain commands. You want to start the job, you want to stop the job. You may want to store the job in the machine itself because it's not quite ready to start, because you don't have all the materials in place. Or you can store it and then start it automatically as soon as the materials are there. You want to define what materials to use, what materials are consumed, equipment potentially to use, the work master or master recipe that you'd want to use to run that job. Maybe that's an optional thing that's on it. So you had these job orders that we wanted to send to a piece of production equipment to say, we want you to execute this job. It might be a recipe, it might be a batch, it might be a manual procedure, it might be just a set of commands that go down to a PLC. And we also wanted to get the information back as a job response based on, again, the ISA 95 Part 4 job response model. And what this defines is the result of execution of the unit of work, such as producing a package or packaging a material in the boxes and the cartons and the cases and all these other things, or the pill packs that you may have out there. You'd also like to know what's going on. Is this current job, is it waiting or is it running? Is it paused or it's stopped, or has something happened? Is it aborted? And then finally, you'd like to get the report back that says, okay, well, what materials did you actually use? What did you actually consume? What was produced? What personnel was actually used? These sort of things that are very important, particularly when we start to look at serialization, because the labels themselves are materials. They may be consumed, they may be destroyed, lots of different things can happen to them. And then how long did it take? Start and stop time. So these were the sort of things that we were looking at in terms of controlling the production lines. Now, to give you some idea what this ISA 95 Part 4 job control is and what a job order is, I've got to show you a little piece of the ISA 95 standard, or which is also the ISO 62264-4 standard. And what it defines is that there is a work schedule that gets developed. That work schedule has a whole bunch of related work requests, and those work requests are made up of job orders, and each job order relates to some sort of work center that is out there. That might be a packaging line or a palletizing line or a production line. It could even be an automated guided vehicle or a warehouse management system. But basically, you're scheduling via some sort of MES system or MOM system these jobs inside the work request to meet what your schedule is. And each of those jobs relates to some workmaster. Again, this is ISA 95 terminology that says this is how this job should be performed. Maybe there's a procedure in there, maybe it's a recipe, maybe it's a flow chart, maybe it's just a simple set of instructions that you provide to the operator. But the work schedule breaks down the work request depending upon how the work's to be split, and then you break that down into work centers that relate to the individual jobs. So this is what we're talking about in the schedule. We're going to send down a job order at some point in time to some specific pieces of equipment and say, here is what we want you to run. Here's the work master. Sometimes these pieces of equipment have multiple work masters. Sometimes they're dedicated, so it's an optional element in there. And we want you to execute it, and we'll tell you when it should be executed. So in order to create these things, we had an advantage because we're starting with the ISA 95 models. We actually had we already had object models to start with. So we used the object models for a job order, and you can see on here that you can pass parameters, personnel requirements, equipment requirements, asset requirements, material requirements down with the job And likewise, when you have a job response, you can get similar things back. Response data, how much you actually used in terms of material, what physical asset you actually used, or equipment you actually used, and then personnel. So we created a couple OPC UA object types in order to make this all work. We have an ISA 95 job order receiver object type, which is quite a long name, but that's what we have to do to make it unique. It contains methods that receive job order commands. So basically, this would be an OPC UA server sitting in the machine that has a job order receiver object type, and it contains methods that a client would call it that says, here is a job I want you to store, or here's a job I want you to start. And then here's the definitions associated with it. So that's what we have to send a job control down. I'll show you the object model here in a second, the OPC UA model. Likewise, we also had two situations for information coming back. Job responses, which were solicited, which meant that the server sitting in the equipment is waiting there for somebody to ask, to say, please give me the response for this associated job, what actually happened, what its current status is it running, is it finished, etc. That's the solicited job responses. The other way to look at it, it's an unsolicited job response. So that piece of equipment down there will basically finish and then send off a method to a job response receiver object type. So basically, this would be on some system, such as an MES system, a job response receiver object type, and it would be sitting there waiting for a job response to come in. So it's unsolicited. But we had both of those situations that we had to look at, both a solicited response that says, give me the data, and an unsolicited that would be sent whenever the underlying piece of equipment actually finished. So to do these situations, we created several different OPC UA object types that would show up inside a server. And the first one was the job order receiver object type. So I'll give you just a couple minutes here and explain some of this. You can see that there's a set of methods here: store, store and start, update, stop, cancel, etc. There is a state model, and I'll show you the state model shortly, that relates to these. So basically, these are the methods that allow you to control any individual job. So when you then send down the method, you're also sending down a job ID, because the job ID comes from the client that is telling it to start the job. And that client would probably be an MES system, again in place, that is sending down the job to say, okay, once you get this started, the job ID is 26, and then at some point in time it'll say, okay, start 26 or update 26 or pause or resume it. One of the other things you'd like to do is be able to see what jobs are actually down in the machine. What is it actually running, and potentially what has it run but it hasn't cleared out yet. It hasn't given you the data back yet. And part of this is, again, a synchronization issue. Some of these machines that we've been talking about are fairly complicated, and they can manage multiple downloaded jobs simultaneously. The reason they want to do that is they want to keep that machine very busy. So you don't want to stop when one job is done, wait for somebody to download a new job, and then start that job. You'd like to have a list of jobs that are available. Likewise, you may have information from that job, but you can't necessarily send it up to the client because the client's not ready to receive it yet. So it maintains the list of jobs that have actually been executed and the parameters associated with it. Now, in order to make this all work, we also had to have what workmasters that job order receiver type can accept. So for example, let's assume you had a packaging line and you could package 3 or 4 different, let's say 4 different types of packages out there. You would, when you send the job down, tell it which of those 4 as the workmaster that you want to have. And there may be some additional parameters associated with it. For example, how many cartons go into a case? How many cases go onto a pallet? Simple things like that, or very complicated parameters associated with it. So for example, a parameter might be the date of manufacture that shows up in a label that you print. It might be the expiration date that you get from your regulatory systems out there. But in order to make this also work, you also have to expose not just the what work masters are allowable with the job order, but also what material classes, definitions, physical assets, personnel, etc., that you can use in a job order itself. Because the last thing you want to do is send a job order to a machine and it doesn't understand it. So the idea of the systems that we have over here, the class ID and the definition ID, equipment ID, are so that the client can confirm, hey, yes, this machine can accept these jobs and has the right information on it. So this is the job order receiver type that we have defined. And here's the state model for that job order. Now, many times when you're running a state model, you're looking at an OPC UA, you're looking generally at a state model of a piece of equipment. Well, in this case, we're not really looking at a state model on a piece of equipment. We're looking at an activity that's going on inside the equipment. And you may have multiple jobs down there. You may have multiple jobs that are downloaded but not yet allowed to start. And then you may have one that's starting. Some machines are very complicated. You can actually run multiple jobs at the same time. The state model basically says, okay, the job's not in the system, and you can either send a job down to start or send a job down and say it's not ready to start. The red are the OPC UA methods that are available to control it. The black lines, the black small lines, are the internal state transitions. So your machine itself is saying, okay, I am, for example, allowed to start. And it goes into the waiting state, then it's ready, and then it's loaded, which means the material is all loaded and it's ready to start running. And then it will itself say, okay, now I can start running because I was allowed to start. It may then stop or be stopped. You may resume it, held or resumed. Again, these relate to the fact that there is a state where I am held because of something external, or I'm suspended, or I'm held because of something, external, or I'm suspended because of something internal that happened. You know, my upstream or my downstream equipment is not yet ready, so I'm in an interrupted state, and then I can go back to running until I'm finally done. And then, because we said we can store the results of the end state, so the job's not really in any of these states, eventually after you get the job response back, you do a clear that simply says, okay, I can now clear out the information that I was saving, clear out the job response data and the job order data because it's done and I'm not going to need it again. So that's the job order state model. These are the methods that we use in order to get and to control the job orders. Now, how does this work coming back? Well, coming back, essentially, it says here's the unsolicited job response requests. Those unsolicited one says I have this job response provider object type, and it contains a method to receive the unsolicited responses. So I've got an OPC UA client, okay, and that client is basically going down and saying, okay, start the job, okay, and then at some point in time, the client comes back and polls and says, hey, what's the status of the job? Is it ended or not? Is it running, etc.? It does a request job response. So this object sits in the machine itself, not on the client side or the MES side, but in the machine itself. And it's either the job order receiver or the job response provider object type. You have this job response here. So the store and start is the job order receiver method. The request job response is the job response provider method. So this gives you the capability to do a poll, essentially, if you want to find out what's going on. Now, you don't necessarily have to do that because you can also do a notification on changes to the job list. And when the job list changes, that means the state has changed, so you can get an exception. So you don't necessarily have to poll to go get the response, but in this case, you can use a standard client to talk to this device. You don't have to have a special purpose client that actually has a server inside it. This is for the unsolicited response, where basically I'm going to ask you for the data and you're going to send it back to me. The other case we have is the job response receiver object type. And in this case, what happens is you have to have the servers on both sides, essentially. You have an OPC UA client and a server that contains the job response object receiver type. So basically, you send down the store and start, and that job will execute, and when the job is finished, it will send it back using the method to say, hey, receive this job response. That will then go back and do a clear. It says, okay, I got it. You can now clear out your memory and whatever it is you've been doing in there. So this handles the case where the equipment itself will basically just, when it finishes, send the data back. We had both situations. Like I say, the big difference here is that in one case, in the previous case, you only needed an OPC UA client, but in this case, you need to have an OPC UA client and a server at the MES level, or for example, at the MES level. So you give us some idea of what we have been working on in these OPC UA job control spec, but we had to do something else in addition to actually customize it both for OPEN-SCS and, as you will see, for VDMA and machinery control. So for the OPEN-SCS, we basically created a thing called a job control profile, which is, think of it as a mini companion spec. It's OPC 30261. It doesn't really define any new object types, but it does define an object space where these OPC UA objects would reside, and the reason for that is, again, so you can browse these and know exactly where these objects exist. It also specifies required units of measure, okay, from the OPEN-SCS spec. Now, normally you would not think of these, but the units of measure in a serialization problem is things like cartons and cases and pill packs and pallets and those sort of things, which are not what people oftentimes think of as units of measure, but those are the units of measure that we actually have to have in order to control these and in order to do our communication with the various supply chains that are out there and the various governmental regulatory agencies. We also specify material properties, and again, the material properties here are very unique to what OPEN-SCS was looking at, which was essentially life science and consumer products serialization and serial numbers. So we have several specific properties that we said people have to support, and we did that with conformance units, profiles, and facets in order to test compliance. So it's kind of a mini companion spec that simply says take the general one and now apply it specifically to my industry, my problem space here. But there is a way to check compliance to make sure that you are actually supporting all the units of measure, material properties, and the OPC UA object types that are out there. So that was all done with the OPEN-SCS working group. The OPC UA for Machinery Part 3 Job Management, OPC UA 40001-3, which you will hear about also today. That's in a release candidate right now, 2023-07-01, and it basically created a job management type which contains within it the job order control and job order results type, which are the previous ones we talked about. And it also defines conformance units, profiles, and facets to test job management conformance. So in summary, to talk about this, what we've basically done with the job control companion specification is give you a way to control the execution of jobs on equipment, in production lines, in any other piece of equipment where you basically say, I want you to do the job, but I'm not going to tell you how to do the job. You've probably got that coded in as a recipe or as a procedure or something like that. But we do want to control the jobs. We do want to see what you're doing. Now, we've had several other companion specification groups, some working groups looking at job control. And my hope is that they'll be able to take what we've done in the ISA 95 job control management, and as they've done in the machinery part, define an object that contains the job order object types and job response object types, or as we've done in the OPEN-SCS, to define a companion spec that says, okay, use the standard one here's where these pieces exist. So I want to thank you for listening to this. I hope that if you have the need for job controls in your system, you'll take a look at what these companion specs are. We do have, as I say, the conforming units, profiles, facets, and all the other pieces associated with it that make it a first-class companion specification in the OPC UA universe. So thank you very much. I appreciate the time, and I hope that you all learned something from this.